You're going to hear a lot more from them in a couple of minutes. But as we get started, just a little bit of an overview of what's going to happen during today's event. I'll go through some general introductions. We'll have our featured speakers introduce themselves. And then during their presentations, we're going to actually start with Ann Wynn, and then Nicole Lunning will finish us off. And during their presentations, they will ask periodic questions. And answers to those questions should go in the chat. Do make sure your chat is set to all panelists and attendees so that we can see what kinds of answers are coming in and you can see them as well. And that's if you're on the Zoom meeting. If you are watching the YouTube live, as we ask questions, think about how you might answer those questions as well. One last note, as you put answers in the chat, for those of you on the Zoom webinar, try to put your school or organization first so we can call out and recognize you and your group. Now, I really want to take a moment to welcome all of our participants. We have folks from 33 different states, Washington, D.C., as well as Mexico. We have educators and students in grades 3 through 12, as well as adult educators. So we are so happy to have all of you with us today. I also want to take a moment to specially thank our Infiniscope at Arizona State University partners. This webinar, they are enabling us to host it. They are enabling us to stream it live on their Infiniscope YouTube channel. So we are so thankful to them and their organization for all their support. And that's namely Sina Kirk and Jessica Swan. So thank you so much. Their infiniscope.org website offers lots of information and resources for educators. So if you've never checked that out, I encourage you to do so. But I mostly want to welcome our featured speakers, Ann Wynn and Nicole Lunning. They are two very busy individuals who are very excited to share with you a little bit about OSIRIS-REx at Bennu. And so with that, I'm going to stop myself from introducing the event and start going to our speakers. So we're going to start with Nicole and have her tell you a little bit about herself. So Nicole, over to you.
Hi, so I'm Nicole Lunning. I'm originally from Minneapolis, Minnesota, where I went to public school through high school. I then went and did a master's degree and before that a bachelor's degree where I primarily studied geology. For my PhD, I went to the University of Tennessee at Knoxville, where I focused on planetary geology, particularly meteorite studies and early solar system studies. I also worked at the Smithsonian, both working in the meteorite collection at the National Museum of Natural History in DC, and also doing research there. I'm actually a pretty new addition to NASA. I started at Johnson Space Center in March of this year. I also do research that involves experiments, so particularly experiments where we actually, under controlled conditions, heat and controlled pressures, sort of melt rocks to simulate planetary formation processes, and particularly for me, the formation processes that happened before the formation of the planets. And actually, not quite a year ago, I went to Antarctica as a field team member in the Antarctic search for meteorites. So next slide, please. I have a few pictures of that. So this is a US-based program that's joint between NASA, the Smithsonian Institution, the National Science Foundation, NSF, and Case Western Reserve University in Cleveland. And almost every year they send a field team down to collect meteorites. We go to different locations in the Transantarctic Mountains. So basically a plane lands on the ice. You can see the skied aircraft there, dropped our field team members off, and then we were alone, just the 8 of us, for about a month, living in Scott tents like what you see. And even though it's the summer in Antarctica when we went, it was winter up here in the Northern Hemisphere, it was still consistently below 0 degrees Fahrenheit. Our team collected over 300 meteorites, which now have been shipped back to Johnson Space Center for their first stages of curation. So on to Anne, I think. Thanks.
All right, so now let's hear from Ann Wynn. And for any of you out there that like the cold weather and like rocks, maybe you someday can be a searcher for meteorites in Antarctica as well. So thank you, Nicole. And on to Anne. Now, Anne, it looks like you are talking, but for some reason I'm not hearing you.
Um, can you hear me?
Yes, I think I can hear you now.
Okay, things are kind of slow on my end. Is my preview slide showing?
Yes, we see your Journey to NASA slide for your introductions.
Okay. I guess there's a lag because I don't see that, but I'll continue talking anyways. So I was born and grew up in Virginia, and as a little girl, I really liked Cabbage Patch Kids, and also I wanted to be an astronaut. And when I went to college at UNC Chapel Hill, I really fell in love with chemistry. And that was my major, but I still had that strong love for astronomy and space. So I figured out a way to combine those two loves, chemistry and astronomy. And I went to graduate school at Washington University in St. Louis. And that's a picture of me with my advisor. And there I studied meteorites, which come from asteroids. And particularly, I studied particles, tiny, tiny particles within them that actually come from other stars outside of our solar system. So I continued those studies as a postdoc at Carnegie Institution of Washington. And I came to NASA in 2008 as a contractor. And earlier this year, I transitioned to the civil service side. I guess next slide, please. So one of the things I really love to do is to travel. And what's great and take photography. And what's great about the field that I'm in is being able to travel to many exotic places for scientific conferences. So I've actually been able to go to every continent except for Antarctica, which I know Nicole was lucky enough to go to. So that's one of the perks I get. Another love of mine is cats. If you'll share the next slide. So these are just some of the cats that I have seen and photographed during my travels, and also ones that I own and have fostered. And the next slide. And currently my main love is my 2-year-old baby girl. And I just wonder every day what she's going to grow up to be. Maybe she'll be a doctor, who knows? She's playing one there. And that's it for now. Thanks.
Awesome. Thank you so much. So, we really think it's so important for you all to get a sense of our scientists. They are scientists, they work in labs, but they're also real people too. So, that's a little bit about their backgrounds. So, now let's get into the what you're all here for, especially to learn about OSIRIS-REx at Bennu. So, Anne, if you would like to open up your presentation and share it, hopefully things will work smoothly for you. So, Anne, I'm going to turn it over to you and your presentation. And as we stand by, we as I'm sure some of you have experienced before, sometimes we have some technical difficulties. And now I do see Anne's presentation up. So Anne, it looks like you are good to go. And I think we will not share videos during the presentations. Maybe that will help with some bandwidth.
Okay. Let's see if I can get pointer. Okay, do you all see a pointer up?
I don't think I see your pointer, but we should be able to see your mouse move. Oh, yes, I see the pointer. Yes, I certainly
Okay, good.
do.
Okay, great. Thank you all so much for joining us today to learn about OSIRIS-REx. This is a mission to return samples from asteroid Bennu. And OSIRIS-REx was selected by NASA in 2011 to go to an asteroid and bring back a sample for us to study in the labs. Now, OSIRIS-REx seeks to answer questions such as where did we come from, what is our destiny, and asteroids, which are the leftover debris from solar system formation, can help answer these questions and teach us about the history of our solar system. Okay, you should be seeing the next slide. Okay, great. So here's a picture of the spacecraft. Sorry, there's a plane flying over our house right now. So here's a picture of the spacecraft and the payload, which did carry this precious cargo into space. And this is our principal investigator of the mission, Dante Loretta, who's a professor at the University of Arizona. Now, people at NASA and those who work in the field really love acronyms. And so here is what OSIRIS-REx stands for. Origins. The mission will try to help us learn how life started here on Earth. Did asteroids play a role in delivering inorganic matter to Earth? Spectral interpretation. What is out there? What is the asteroid made of? Does it contain water? Resource identification. Do asteroids contain, excuse me, do asteroids contain materials that we can use for fuel, such as water, organics, and precious metals? In the future, these asteroids may fuel spacecrafts so they can explore the solar system. Security. Can we prevent an asteroid from hitting the Earth? Now, Bennu is one of the most potentially hazardous asteroids. It could impact the Earth late in the 22nd century, and OSIRIS-REx will determine Bennu's physical and chemical properties, which is very important to know in case we need to prevent an impact. And last but not least, Regolith Explorer. So let's bring home some of the asteroid to study in our labs. Okay. OSIRIS-REx aims to address key questions about the solar system, such as how did the sun's family of planets and minor bodies originate? What are the characteristics of the solar system that led to the origin of life? How did life begin and evolve on Earth, and has it evolved elsewhere in the solar system? How did the solar system evolve to its current diverse state? And what are the hazards and resources in the solar system environment that will affect the extension of human presence in space? So during the presentation, I asked you to think about how these questions may be answered by the mission. This image shows the configuration of our solar system. We have the inner solar system where the sun and Earth are, and the outer solar system where the giant planets and some comets reside. And beyond Neptune is the trans-Neptunian region where we have Pluto and other dwarf planets and the Kuiper Belt. Now, the inner solar system and outer solar system are separated by this asteroid belt, which was discovered in 1801. Now, the asteroid belt looks like the Kuiper Belt, but the Kuiper Belt objects are icy bodies, whereas the asteroid belt contains rocky bodies. And these rocks are chunks that were left over from when our solar system formed. And the rocks were not able to fuse together into larger planets like our Earth. So there's a group of asteroids that are called near-Earth asteroids, or NEAs, and they have different orbits than asteroids in the main belt. Now, these objects come much closer to Earth's orbit. As you can see here, the blue lines are the near-Earth asteroid orbits. And scientists keep track of their paths to make sure none of them will impact us, and like the asteroid that took out the dinosaurs millions of years ago. So if the orbit of an NEA crosses the Earth's orbit,
Now, I think we might have had a technical difficulty and we may have lost Anne for a moment. And you dropped off from your presentation. And so we're no longer hearing you and we're no longer seeing your presentation. So stand by, everyone. Technical difficulties. We'll work through this.
Oh, okay. Am I back on? Can you hear
You
me?
are back on. Yes, we certainly can.
Okay, let
We're
me
no longer
try.
seeing, yes, your presentation.
Okay. Let me know when you can see it.
I can see it again now.
Okay, great. Should I just start from this slide? Is this kind of where I dropped off?
You dropped off after you talked about NEAs crossing Earth's orbit.
Okay. So Bennu is considered a potentially hazardous object because it comes very close to Earth and is rather large. But luckily, calculations indicate that we are safe from impact for another 100 years. Okay. So scientists are able to characterize asteroids and other planetary bodies remotely using various techniques such as radar astronomy, photometry, astrometry, spectroscopy, and scattering properties. Bennu has been studied by all of these telescopes that you see here, so it was very well characterized even before OSIRIS-REx launched. So these telescopic studies have allowed us to know Bennu's orbit very well. As you can see on the right, that's Bennu's trajectory in the solar system. And we know that it is about 500 meters in size. It has this spinning top shape, and it makes a complete rotation in just 4.3 hours. Now, one of the mission objectives is to compare these ground-based observations to those that are made by the spacecraft and also to our analyses of the sample itself. So this will help us determine how well these remote methods can characterize these distant objects. So to give you a sense of how big Bennu is, here is an image of Bennu next to the Empire State Building and the Eiffel Tower. And as you can see, Bennu is larger than both buildings. So it is nearly a third of a mile across its center here, and its circumference is about a mile long. So out of over 500,000 known asteroids, how did scientists choose to go to asteroid Bennu? Scientists chose Bennu because of its proximity to Earth. Its orbit makes it accessible by spacecraft and also promising for sample return. Also, its size is appropriate. Asteroids that are smaller than 200 meters spin too fast and eject the loose rock from its surface. Now, this loose rock is known as regolith, and that is a material that we want to collect and study. It's also harder to get a spacecraft to come in contact with a fast-spinning body. Bennu is also very primitive and carbon-rich, so it is likely that organic matter and possibly water can be found on Bennu. So we hope to collect organic molecules on Bennu that are like those that may have led to life on Earth. Now, asteroid Bennu wasn't always called Bennu. The mission name has parallels to the Egyptian god Osiris, who was the son of the sky and earth, and he brought agriculture and life to the world. And one goal of OSIRIS-REx is to return organic-rich asteroid material that may have led to life on Earth. So there's a parallel with the mythological god Osiris. Now, asteroid Bennu used to be called 1999 RQ36, and in 2013, a 9-year-old from North Carolina entered the name Bennu to the Name That Asteroid International Student Contest and won. Now, Bennu is an Egyptian mythological bird, shown here, that was born from the heart of Osiris. And this bird is associated with the sun, creation, and rebirth. And the student that won the contest thought that the wings of the bird looked like these solar panels on the spacecraft, and that the legs look like the tag arm on the spacecraft. So you can see the resemblance there. So this name is very appropriate for the mission. Here is briefly the mission timeline. The OSIRIS-REx mission was selected by NASA in 2011, and the spacecraft assembly began in 2015, and it launched in September of 2016. It took 2 years for the spacecraft to reach Bennu, and in just 5 days, the spacecraft will finally collect a sample from the asteroid. It will depart next year from Bennu and return to Earth in 2023. Now here are images of the spacecraft, which was designed and built by Lockheed Martin. On the left are images of the spacecraft construction, which took place in a clean room. So in a clean room, anyone who enters has to wear what they call a bunny suit in order to avoid contaminating the spacecraft and the sensitive instrumentation that's on board. And this is a picture of the spacecraft all finished up. So with the solar panels deployed, the spacecraft is 20 feet in length, and it has a width of 8 feet and a height of about 10 feet. So the size can be compared to a 15-passenger van. Now it weighs 1,940 pounds without fuel, and with fuel it weighs 4,650 pounds, which is about 2.3 tons. The spacecraft has multiple instruments on board that will be used to characterize and map the asteroid on global and site-specific scales. So with these instruments, it can obtain chemical, mineral, and temperature information, and also determine the surface topography. Now, I want to point out the tag SAM, which is tucked away here, and this is the mechanism that will be used to acquire the sample. And also the SAM-CAM is one of the cameras that's on board. And the SAM-CAM will image the sample site and also the sampling process in order to evaluate success of the mission in acquiring a sample. So the launch of OSIRIS-REx took place on September 8th, 2016 at Cape Canaveral in Florida at Kennedy Space Center. And I almost went to this launch and I really regret not going. From what I hear, it was just an absolutely perfect launch. And here are some really stunning images of that event. So after being in flight for nearly 40 days, OSIRIS-REx caught a first glimpse of its target, asteroid Bennu. This was taken on August 17th of 2018. As you can see, it just looks like a little pixel going across the screen, and it's quite indistinct at this point. So at this time, the spacecraft was 1.4 million miles away from Bennu. After an additional 3.5 months of flight, the spacecraft was able to capture these absolutely splendid views of the asteroid when it was only 15 miles away. So OSIRIS-REx then spent a year mapping Bennu, and this allows scientists to make lots of interesting observations. So what observations can you make about Bennu based on these images? Please list them in the chat.
All right, so as you're putting in your answers in the chat, try to put your school or org name first so we can perhaps acknowledge you, and we'll see what types of observations you can make. Now, if you're watching on YouTube Live or you're watching the archive of this, think to yourself what observations you can make. So Creekview High School says, looks like there's plenty of regolith to choose from. SDA in Georgia says it's gritty. Our solar system ambassador says from New York says it looks like a ball of dust. Another solar system ambassador says it's really rocky, not too smooth at all. Another solar system ambassador is mentioning there looks like there's lots of rocks, evidence of erosion. Space St. Croix says perhaps some loose material. Another one of our folks from Illinois says it's non-spherical in shape, several large boulders, and perhaps a lot of regolith. We're also getting it's a rough, rocky surface from our solar system ambassador in South Carolina, irregular shape from one of our school groups, and kind of dusty, lots of debris. Even Randall Middle School says it's not very smooth, very oddly shaped. It's certainly not spherical. Now, our elementary group down says it looks rough, lots of gravel like material, and it's almost like a cube on its side. And someone's even saying it looks a little even bright. So we've got some very interesting observations there. Even from Riverton, it says it almost looks a little bit like a burnt marshmallow. So sometimes you can almost see things and make some associations with them. But overall, from a scientific point of view, and it looks like some people are saying they can see regolith, but they can also see rocks. So what are we seeing? And thank you all for your answers.
Wow, those were some really, really great observations. And some of those observations were actually made by the scientists as well. So good job, everybody. All right, so the first surprise that some of you mentioned already is that Bennu is very rocky. So this was extremely surprising to see this rough and rocky texture. From remote studies from our telescopes, scientists expect the surface of Bennu to be fine-grained, like a sandy beach. And that's not what we see here. The terrain is very rugged, and it's littered with boulders as big as cars, houses, and even football fields. So the largest boulder on Bennu is called Ben, and you might have seen that in the previous images. And Ben is as tall as a 6-story building. And this rocky terrain makes sample collection more challenging, which I'll talk a little bit more about later. Another surprise is that Bennu is active. So cameras saw these plumes of dust particles being ejected into space. And this is the first time that such activity has been observed on an asteroid. And scientists are still trying to figure out what causes it. So in comets, plumes are caused when ice sublimates, but asteroids form too close to the sun to have ice on it. So we still don't know what exactly causes these plumes. Now, a third surprise is that Bennu has boulders from another asteroid on its surface. So one striking feature of Bennu is how dark the rocks are. But the OSIRIS camera suite saw these 6 very bright boulders across the southern surface, and these boulders really stand out, and they were analyzed by the spectrometer on board, which revealed that they have a different composition than the rest of Bennu material. So in fact, the composition matches material from another asteroid Vesta. And Vesta is made up of high temperature mineral pyroxene. So how did these boulders end up on Bennu? Okay, I'm going to try to share a video. Okay, hopefully you can see this video.
Yes, we can.
Okay. So, oops, are you still seeing the video?
It disappeared. Oh, now it's back.
Okay. Let's see. Sorry, let me try to play that again. I'm sorry, I kind of missed it. Okay, so space can be quite a violent environment with lots of bombardments. And Bennu is what they call a rubble pile asteroids that scientists think formed when a parent asteroid was struck by a fragment of asteroid Vesta. And the parent asteroid broke up, and some of the rocky debris, including some of that Vesta fragment, reaccumulated by gravity to form Bennu. So if you just want to see this one more time, let's imagine that that's Bennu's parent asteroid, and it's being bombarded by a piece of perhaps Vesta. And all these rocks broke up, and some of them reaccumulate and form another baby asteroid in a way. And that's how they think Bennu formed. Okay, let me try to share my slides again. Okay, can you see my next slide?
Yes.
Great. So mapping the surface of Bennu was also important so that we can select where to land the spacecraft to get a sample using the TAGSAM touch and go sample acquisition mechanism, which is shown in this depiction of the spacecraft here. So what considerations do you think went into choosing the sample site on Bennu? Please put your answers in the chat.
And so now we're really having you think about being a scientist as well as an engineer. So right off the bat, and again, if you try to put your school or org name in there for starters, then we can at least recognize some of those groups on the line. So thinking about considerations in choosing a sample site. We have one answer that's come in that says the flatness and size of the surface. Another talking about an area to avoid damage to the spacecraft. And one of our solar system ambassadors from Oregon says a safe operation for the spacecraft must be necessary. Space St. Croix says a lack of large obstructions, and that was one of their particular students. We also have an area where TAGSAM can actually fit in and collect. One of our solar system ambassadors from Boston says minimal number of large rocks or low angular movement. Safety is of the essence, is one of our solar system ambassadors from California. Relatively smooth and rock free, has to be safe enough to avoid the boulders. Regolith diversity. Now, Meadow Creek High School is saying so much math and trajectory timing, all of that has to probably come into consideration. Truman Elementary says safety of the spacecraft. And even Creekview High School says someplace flat to be able to touch down, different types of rock samples, perhaps based on color, chemical composition. So we've got some real detail there from that high school group. Also, some of our other solar system ambassadors are saying the orbit and timing has to come into consideration. Space St. Croix, a flat enough area to make good contact. And Meadow Creek also adds in the tools have to be tough enough to withstand the, I'll put this in quotes, they didn't, the impact or the touchdown. It should be gentle. So we've got some very detailed answers in there, Anne. Tell us what kinds of considerations went into this.
That was extremely impressive, you guys. I think there are some definite future scientists out there. All of your answers were really great. So what did go into choosing a sample site? One was deliverability. So the spacecraft has to be maneuvered in and out of the site easily. Also, they had to ensure safety, as some of you said. So when the TAGSAM head contacts the surface, the spacecraft must avoid any damage. Sampleability. So the sample site has to have rocks and debris that are 2 centimeters or smaller so that the TAGSAM head can capture it. And also science value. The sample site should have pristine regolith with carbon-rich, diverse, and primitive materials, and also hydrated minerals. Those are the things that we're looking for. And these materials, we can analyze them and they'll help us answer questions about our solar system and about how life came to be. So here are the 4 candidate sample collection sites that were selected in August of 2019. We have Nightingale up here, Kingfisher, Osprey, and Sandpiper. Now these sites were named after birds that are native to Egypt in keeping with the Egyptian theme. And all 4 of these sites fit the 4 criteria for site selection. Again, it's deliverability, safety, sampleability, and science value. However, I want to point out that the original mission was designed to sample in a site that was hazard-free. As somebody said, with only small rocks the size of a dime, flat within a 50-meter radius. Now remember, they thought Bennu was going to be like a sandy beach. And surprisingly, when they came to Bennu, they could not find a site to fit those original criteria. So they had to make some adjustments to their sampling plan. Okay, next I'm going to show a video. Okay. Do you see this OSIRIS video?
Yes, we do.
Okay. So this shows the sample sites by the laser altimeter. This first site is Kingfisher, which is about 10 meters in size. Notice how they're alike or different. Notice the boulders on them. Okay, this is Nightingale. And Sandpiper. So hopefully you could see that there are some similarities and differences between the different sites. Let me go back to my PowerPoint. Okay, are you seeing my slide again?
Yes.
Okay. Okay, so out of the 4 potential sites, which one would you choose as a primary sample site and why? Remember to keep those 4 criteria in mind and please put your answers in the chat.
So again, though, you gave some great answers about sampleability and shared some of the things to think about. So now we're really asking you to think hard about which of these sites you would choose, but not just which site, the why is also important. So we'll see what kinds of answers we might get in the chat. This is one of the things I'm sure that scientists very actively debated at the time this was happening. And so now we'll see what kinds of inputs you provide. So one of our solar system ambassadors from New York says, Sandpiper, as it has not been impacted by another object, so it looks. Now, don't just give us a name, give us the why. So we've got a solar system ambassador in Illinois that says Osprey due to the openness and the variety of rock sizes. Space St. Croix says Sandpiper because there's good visible collection of different rock samples. Creekview mentions Kingfisher or Osprey because they look like they are smaller samples and less debris surrounding the area. Our solar system ambassador in California says Osprey looks like a recent impact site excavating and exposing deeper material. We've got another individual that says Nightingale because of the flat and safest looking surface. One of our solar system ambassadors from South Carolina says, I think kingfisher, because it looks like safety for the tag operation would be good. Now, our Boston solar system ambassador says nightingale or osprey because of the space available for touchdown and the variety of regolith material. Now, Downs Elementary says osprey or nightingale because it looks like there's small samples available to be picked up. And here's just a couple more. Truman Elementary, nightingale because it looks flat and lots of rocks. And Truman also says it kind of looks soft too. And one of our solar system ambassadors says kingfisher because of the variety of debris, maybe a small impact area. And Meadow Creek agrees with them, but also thinking maybe sandpiper. So I've heard a lot of sandpiper, ospreys, couple not so favorable. So, what did we choose here, Anne?
So, interestingly, after studying these 4 sites further, the 2 final sites were selected in December of 2019, and surprise, Nightingale was chosen as the primary site. I think there was one answer for Nightingale as a primary site, so kudos to you all. And then the secondary site is Osprey. Okay, so why were these sites chosen? So site Nightingale is in a small fresh crater. I noticed someone mentioned fresh craters. That's a good answer. And Nightingale is near Bennu's North Pole right here. Now we know that the material in this crater is fresh because it is spectrally redder than the average material on Bennu. So when surface material is exposed to space weathering for a long time, it turns blue. And most of Bennu's surface is spectrally blue, but Nightingale contains this more fresh red material. So Nightingale is as big as a few parking spots or a tennis court and is surrounded by building-sized boulders. Nightingale was selected as a primary site because it's not as rough as the other sites are, and it has the most fine-grained dark material. It also has the highest color variation, which suggests that there's a variety of material that can be found at the site. So we've chosen Nightingale as our primary site. So how do we get the sample? Okay, so the sample will be collected using TAG-SAM, which is the touch and go sample acquisition mechanism. The TAG-SAM arm is 11 feet long, and it can bend at the shoulder, the elbow, and at the wrist. Now there's this ring-shaped canister within this head where the sample will be collected. And you can also see here, there are these nitrogen bottles. There's 3 of them to be exact. And this nitrogen gas will be used to stir up the regolith. And this sampling mechanism is the first of its kind. Okay, now I'm going to show a video demonstrating how this TAG-SAM works. Okay. Can you please verify if you're seeing the YouTube video?
I am not seeing that video yet.
Okay, let me try again. How about
I see
now?
that up. Yes.
Okay, great. Okay, let's start this. Okay, so this video illustrates the tag event. Here the TAG-SAM arm is extending and the head moves into position. Then the spacecraft slowly descends to the surface of Bennu. And then the arm will touch the surface for just 5 to 10 seconds while injecting this nitrogen gas. And this gas disrupts the regolith material, which is then propelled into the tag SAM collection canister. Then the spacecraft thrusts away and spins around with the arm out to measure the moment of inertia, and that is how they will estimate the mass collected. Once it's determined that we have collected at least 60 grams of material, then we enter the stow sequence, which you just saw, where the sample head is stowed into the sample return capsule, and the arm tucks away. Okay. So there are many hazards during tag that could potentially threaten the mission. Like if the spacecraft landed at an angle or on a large rock, or if it tipped over, or if the tag SAM head lands at an angle. So to avoid such hazards, natural feature tracking will be used to navigate the spacecraft safely to Bennu's surface. Now the spacecraft will take images of geographical landmarks, such as these, as it descends, and compares these images to an onboard image catalog. So the spacecraft uses these markers to orient itself and to accurately get to the touchdown site. Now, the Natural Feature Tracking System also uses hazard maps, which has identified potentially hazardous regions. So if the spacecraft senses that it may touch one of these dangerous regions, which is shown in red here, it will autonomously wave off, back away, and try again another day. But if the area looks good or green in this hazard map, then the spacecraft will proceed to get the sample. Now, there were 2 tag rehearsals. Both of them were successful. There was one in April and one in August. And this is a view of tag from the SAMCAM, which will watch the head during the event. So we know where we landed and we know that sample was collected. Now, during the second rehearsal, the tag SAM head hovered 130 feet above the surface of the Nightingale site. So this makes a successful tag on October 20th very promising. So as you can imagine, it takes a lot of people to make the OSIRIS-REx mission a success, thousands in fact. And here is just a fraction of that big international team. And in here, that's the PI right there. Now, these are the scientists here at NASA Johnson Space Center who will analyze Bennu samples when they return in 2023. And we are lucky enough to have a lot of techniques and instruments that can be used to assess the sample's chemistry, characterize what organic matter it contains. We can also determine its isotopic composition on a very fine scale, and also the crystallography. And we have methods to produce specialized sample extraction. So we can analyze samples on the centimeter scale all the way down to the atomic scale. But before we can analyze these samples, they must be curated in our facilities, and Nicole will talk to you about that aspect.
Awesome. Now, thank you, Anne, for sharing your parts. And as Nicole cues up her presentation, if you do have questions, do put them in the Q&A so that perhaps Anne can go ahead and answer some of those. And Nicole, in the meantime, let's turn things over to you.
All right. Thanks, Anne. That was great. Yeah, so we're transitioning to the curation side of the presentation. And so as you can see here, this is some of our curation team. And I think that nicely transitioned from Anne's slides of we actually have more people on the science side than curation side at Johnson Space Center. But from curation, we have going from left to right, Kevin Ryder, who's actually been involved in the mission since its inception before selection, Keiko, who's done a lot of work in curation in recent years, and then the 3 people on the right, including me in the center, are actually relatively recent additions to the team, Chris Sneed and Rachel Funk as well. So what does it mean to be an astromaterials curator? You probably have a sense somewhat of what a research scientist do, but curation is, although we're all scientists, we have a different hat we wear when we're curators, when we do curation. And I know for me, curation and curator weren't part of my daily vocabularies until I started working in a meteorite collection at the Smithsonian. So I wanted to give you a chance in the chat to kind of talk about what you think maybe astromaterials curators do.
So we're going to see what comes in. And as you think about a curator, think not only about an astromaterials curator, but perhaps librarians, museum folks. There's lots of curators out there. So as we see what types of answers come in, and this is, a growing job for us, a very important one. So now Meadow Creek says to organize and study collections. One of our solar system ambassadors from Indiana says to keep materials safe and free of contamination. Another individual from New York, our solar system ambassador, says catalog sample storage, sample use, and checkout and return. Space St. Croix says, I'm a certified, someone else is out there that can actually get one of our samples, our discs. Truman Elementary says, to collect asteroid pieces. One of our other Illinois solar system ambassadors says to analyze and study samples and preserve samples for future analysis as well. YOLO Library says keep collection, catalog items, acquire samples. And then we have another individual who says preserve pristine samples for scientific analysis, select proposals to support, track and prepare samples for analysis. And Downs Elementary says to take care of the collections. Now, there are many others coming in. I'll read one more. Creekview High School says in-depth analysis is mentioned, historical records for future reference, to divide up and between different labs for further analysis, and study and preserve all of these materials. So we've got some folks that may have an idea out there. What do you think there,
Yeah.
Nicole?
I'm really impressed. You guys did a great job of covering what we do as curators, and I'll get into some of the nitty gritty in some of the slides. So, OSIRIS-REx will join a number of other astromaterials curations at Johnson Space Center. The first, of course, was the samples brought back by the Apollo missions, and as I mentioned before, the Antarctic meteorite collection, which continues to grow and starts its curation process at Johnson Space Center. On this slide, one of the things I just wanted to call your attention to is that bottom row, where you can actually see a lot of curation scientists working, working in glove boxes. These glove boxes typically have inert nitrogen gas in them that preserves the samples so they don't react with Earth's atmosphere. They're all wearing clean lab outfits, also to protect the samples from contamination from people, as some of what we do. Sorry, my slide isn't advancing. There we go. Okay, so for the curation side of OSIRIS-REx, it actually started and needed to start well before we get the samples. So one of the first things that we really started doing was archiving for contamination knowledge and control. And when I explained this to somebody once, they called it sort of CSI, or crime scene investigation, like those TV shows, in reverse. So what we do is we do as much as we can to prevent contamination, right? Both the spacecraft construction and the laboratory that will receive the samples. We do everything as cleanly as possible. And particularly with OSIRIS-REx, since we're really excited about those organic components, we're doing some things a little differently to really, really limit contamination from organic things. The other thing, we do a sort of a double check. We do contamination knowledge, which is essentially monitoring what our contamination could be. We're building this new clean lab to receive the samples currently at Johnson. During the sample recovery, both when it happens in 2023, but leading up to it, we will also do rehearsals so we can do that most effectively. And last, but definitely not least, once the sample's here, the curation team will work with the science team to do the initial description of the samples and to build a catalog, as somebody said in the chat. That was great. So contamination, control, and knowledge. So control, I think, is a little easier to understand. It's working in clean rooms, doing everything you can to prevent contamination from people and just the environment of Earth. But contamination knowledge is a little bit more, or a little bit maybe something you haven't heard as much. And on here you can see, obviously, pre-flight, the spacecraft. You can see on the palette next to it, there's a little thing that I put a red box around. And then there's a larger inset of what this is. And this is what we call witness plates. So during the spacecraft construction, one of these was with the spacecraft, or every part of the spacecraft as it was assembled and tested. They were changed every 30 days, so we have a lot of them. So we have pure aluminum foil and pure silicon wafers. And one of each of these was analyzed after each time to monitor kind of close to in real time what contamination is. But then the other three are archived. And we do that because OSIRIS-REx is doing exploration science. We may find stuff we totally don't expect. And having this sort of chain of witness plates following the spacecraft throughout its journey before and up to launch gives us something we can go back and check. So if we have and prove that something is from Bennu, or hopefully not from Earth if we find something really surprising. And this is just an example. This isn't all the steps the spacecraft went through in its assembly and construction and testing, but you can see the sample return capsule up in the upper left there. And so there were witness plates along with the spacecraft for everything, including transportation from the Lockheed Martin facility to launch from Florida. And I'm just going to quick jump in the middle there, kind of leave off where Anne picked up with the sample collection on Bennu. And then once the sample is in the TAGSAM head, you can see the TAGSAM arm will stow it into the sample return capsule, which is this container with a kind of white conical dome on the top. And so that sample return capsule is actually the only part that's going to come back to Earth. As you'll see in this animation, 3 years after we do this in 2023, September, this will be will return to Earth. It'll pass through the atmosphere, so that upper cone is actually a heat shield. And it will go to the Utah test range. And here you can see it approaching Salt Lake. And hopefully the parachutes will deploy perfectly and it will come to a very gentle landing in the Utah test range, where scientists will pick it up. This switches to a video. Obviously, this isn't the OSIRIS-REx samples because we haven't collected them yet. This is the Stardust samples, which used a very similar sample return capsule. And so here's scientists from JSC and the mission team for that mission collecting that and taking that sample return capsule apart. So, and then within actually the TAGSAM head and the sample return capsule, there are additional witness plates. So we have all the pre-flight witness plates, but we also have witness plates that are going with and will record what the spacecraft may have experienced or anything that could have happened in that part of the journey as well. And so all of this adds value to the collection of the material we get, because we can use this to prove or to test if things that we find are from Bennu rather than from some part of our process. Here's just some pictures of the Utah test range. A little bit before the sample is supposed to be returned, we'll actually build a portable clean lab there. And our colleagues who are involved in building the spacecraft with Lockheed Martin will actually do some initial removal of any potential unexploded ordnance that is in the sample return capsule. And then it will go in a container back to Johnson Space Center, where we'll disassemble it and start to look at what's in it. So we kind of expect two main samples to be in it. The bulk sample, which will be inside of the TAGSAM head, and that video Anne showed you really showed how that part is going to be collected. And we expect that to be most of the mass of the material. The second is not going to be as much mass, but it's an interesting sample. We have material that will be collected by the contact pads. So these are pads. There's 24 of them. They go in these little round circles, and this is the part of the TAGSAM head that's going to touch the asteroid. And each of these contact pads, it's made up of stainless steel fibers. So it's basically almost like stainless steel Velcro. So if you think of the Velcro on your jacket gets little stuff caught in it, in this case, we're trying to have that happen. So we get little particles that we know were on the absolute surface of the asteroid, because there's some things, those are the parts that are directly exposed to the space environment. So there's lots of questions that scientists will be interested in using these samples, but they're very small. My colleague, Christopher Sneed, is an expert in micromanipulation, picking up very small materials, and he did some testing on replicas of the sample pads to develop our techniques. Here's a snapshot of current construction of the OSIRIS-REx lab right now. The drywall's just gone up, so in a few months it will actually be a clean lab. It's not a clean lab yet, but it's on its way. What will happen when we first have the construction phase completed? Well, we're going to start outfitting it with things like these nitrogen cabinets to handle the sample and to protect it from Earth's atmosphere. We're also going to do a bunch of rehearsals to make sure we have everything in place, because we're only going to get one chance to open the sample return capsule and the tag SAM head, and we want to make sure we do it as effectively as possible. And then we'll characterize the returned material and build a catalog with that characterization. So we'll use a combination of microscopes that are inside of our clean lab, but we'll also use some of those great facilities elsewhere at Johnson Space Center that our research colleagues have. And I just want to wrap up with, there's a bunch of ways you can follow the tag event next week on October 20th on the web. So here's some ways you can do that and kind of participate in this exciting collection event with us. Thank you.
Awesome. Well, thank you so much, Nicole and Anne. Now, Nicole, am I correct that you have to depart for another meeting? Is that correct?
Yes, I do.
And we totally understand that and respect your time. So for all of you out there, I want to take a moment to thank Nicole for her time and sharing the curation aspect of the OSIRIS-REx mission. Anne is able to stay on for some additional Q&A. So if you want to stay on the line with us, by all means, please do. It is 2 minutes past the top of the hour. So Nicole, if you have any closing remarks, I'll let you share, and then I know you have to go.
No, thanks for your great interaction, everybody.
Awesome. Thank you, Nicole. And for those of you that are able to stay on the line, we do want to take a few moments to be able to answer some of your questions that you have in the Q&A area. And also, if you are getting ready to leave, I did put a small little link in the chat for you to be able to give us some feedback on today's event. Should only take you a few minutes to fill out, and we really would love to get some of your feedback for doing these types of things again in the future. So if you have to depart, thank you so much for staying with us. If you can stick around, we'll see how many questions we can keep Anne on the line for to be able to answer some questions too. So Anne, I don't know if you had a chance to peruse some of the Q&A and if there are some particular questions you'd like to answer.
Yes, there are several questions that kind of all relate to a similar theme, so I guess I will address that. One is, someone asked, how much can Bennu bring back? So the goal, the minimum amount that they want to bring back is 60 grams of material, but the tag SAM head can capture up to 2,000 grams. So hopefully we get more than the minimum. The minimum was just defined as the amount that we want or that we need in order to do all the analyses that we want to do in the labs here. So I think someone asked, what happens if you don't get 60 grams of material? So after the tag event, in 2 days afterwards, I believe the SAMCAM will look at the tag head to see if there's material there, and then they will do the spin routine to estimate the amount of material. So if it is 60 grams, it will be stowed away, and if it's not, then that is where the backup sites can be used. So we're first going to try at Nightingale. And like I said, we have the three separate nitrogen canisters. So we have 3 tries to get 60 grams of sample. So the backup site would be used if we cannot get 60 grams at the primary Nightingale site. And 3 tags is our limit there.
And Anne, if I can just interrupt for just a quick minute, if you would like to share your camera, we can see if so our folks out there can actually see you.
Oh,
if
sure.
That's a possibility. Awesome.
Okay, I look like I'm frozen on there. Am I frozen?
You'll probably unfreeze, but you are frozen momentarily, but not in a bad way.
Okay. Okay, we'll see if it changes to another frozen state. But something someone else asked is why use nitrogen rather than another type of gas? So we use nitrogen because it's an inert gas. So it's kind of a clean gas. So it doesn't have as many contaminants. It doesn't react with other gases. So that's what we use so that we don't contaminate the sample. That's also what we use in our instrumentation when we're trying to vent the sample, for instance. You don't want to use just air that has contaminants in it. We use clean nitrogen. Let's see if there was another question. Is there a magnetic field on Bennu? No, there is not a magnetic field to capture particles. It doesn't have a core. It doesn't have an iron core like the Earth does, and it doesn't rotate. So it can't produce a magnetic field. And it doesn't really, it can capture particles in a way. The gravity on Bennu is 1/1,000,000th of the gravity on Earth. So when I showed the picture of the plumes, you saw these particles going off of the asteroid, and some of them actually were able to go around Bennu and orbit Bennu and then come back onto its surface. So the smaller particles could still be captured into Bennu's orbit and come back to the surface. The rotation rate of Bennu, Bennu rotates quite fast. It can make one rotation in 4.3 hours. And they've actually found that the rotation rate of Bennu is getting faster with time. So it's good that we're trying to get a sample now before it starts rotating too fast. Let's see if there are any others. Paige, did you see any that?
Yeah,
I tried to answer some, but
there was one in particular about will the samples have to be quarantined in a sense before they're studied, or have we found that we don't anticipate any issues and they'll just go directly into the clean rooms where they'll be worked on?
That's a better question for Nicole, but as far as I know, it will not have to be quarantined. They'll take it to the clean area in the lab to open up the sample at first. So that's kind of the first step, is transporting it safely to Johnson Space Center, to our facilities here, and having it under a clean environment to open up this capsule.
Yeah, and it is a really great question, because planetary protection certainly is something that NASA is big on, whereas even a planetary protection officer. And from the things that I agree with Anne, from our understanding, is that there's no thought or feel. When the moon rocks first came back, things were very uncertain. Do we, are these things going to cause any problems for anybody? And certainly they found they did not. And so I believe the anticipation is that there should be no issue with these samples coming back, but we do keep them as clean as possible to protect the samples from any contamination. Now, here's another question that I think some of this news might have recently come out. Do you know when the tag event will actually be taking place? I know it is on the 20th. And I think I just saw a time in which that will occur. Do you recollect?
I did recently get word about that, but I can't remember the exact time. Now, if you go to asteroidmission.org, I believe they're going to have some broadcasting and pre-event interviews and things on the 20th. So you might want to look to that website for more information on the day.
Yes, and someone else had asked about that sort of a pre-event party kind of thing. And so, like Anne said, those sites where they'll be having lots of news and not lots of information. And I'm looking at the nominal sample collection attempt is scheduled for 6:12 p.m. Eastern time. And I'm cheating because I can look things up from documents that Keiko just sent out yesterday to be able to read that off. So that I don't happen to know that off the top of my head. I'm looking at a document that mentions that. But like Anne said, take a look at those sort of little event, and you'll get even more information as this exciting time occurs. Now, Anne, what will you be doing during the tag event? Share with us. I mean, is there any special thing you'll be doing?
Well, I'll probably be joining in on the tag festivities. I think, like you said, Creation is holding one of those, so I think I'll be joining in with our Aries team and our scientists here to kind of celebrate the event. And I do have a bottle of champagne, so if it's successful, then I might break that out.
And
Yeah, it's just
it
go
is
ahead.
a very exciting time. Is this the first time NASA has attempted to sample an asteroid?
Yes, this is the first time that NASA has sampled an asteroid. The other sample return mission that you may have heard of was Stardust, and that went to Comet Wilt 2 and captured samples from the tail of the comet. And that brought back very little material, like micrograms of material, but even with that small amount, we've learned so much more about comets. So, I mean, 60 grams doesn't sound like a lot necessarily, but we can really do a lot of science with 60 grams. So I really anticipate learning a lot about asteroid Bennu. It's really fun because you don't really know what to expect. Just like when OSIRIS-REx spacecraft reached Bennu, it looked completely different than what they anticipated. And I feel like we have clues as to what we're going to find in the actual samples, but I know that Bennu is going to throw us some surprises there as well. They've already seen that the rock type on Bennu could be very unique and different than any meteorites that we have in our collection. So this could be genuinely a new sample that we haven't seen yet.
And as you were speaking, you actually gave me chills just thinking about that. And for the
Yeah.
students and the folks that work with, the general public or students or patrons, science is such a powerful part of exploration. And the more we learn and the more we know, the more questions that get generated. And so,
Mm-hmm.
you're looking at Anne, who is, a relatively um, young scientist that's recently joined our NASA team and has been looking for these samples to come back and is so excited about it. But our kids that are sitting in classrooms today, they are the future Anns and Nicoles and Dante Lorettos as PIs of missions and the other folks that are on our teams. And so the future, these samples, though the official mission is 2 years once the samples come back, but I'm sure the studies of those samples will go on for many, many years. Do you agree with that,
Oh,
Anne?
absolutely. I mean, we're still studying Apollo samples to this day, 40 years later. So, or more than that, actually. um, so certainly the sample that we get, we'll learn a lot about it now, but as techniques evolve, like the instrument that I work on mainly only came to being 20 years ago. Who knows, 20 years from now, what we'll be able to do, what you guys will be able to do, and new analyses that can be made. So there's always something new to learn from these samples. So it's kind of like the gift that will keep on giving, let's just say. And, I want you all just to know that space exploration is extremely challenging, but it is so rewarding and it is absolutely possible. So, I don't want to be a cliche and say reach for the stars, but we really can do a lot if we put our minds to it.
Absolutely, and teamwork is the key, as you saw the large set of team members and even more that are a part of a mission like this. So you all out there are seeing history in the making, and so this is a really, really exciting time. Do you have a few more minutes for a few more questions, Anne?
Yeah, I can hang on for a few more minutes.
Okay. Well, here's a question that, relates to a little bit of what you were talking about earlier. And when you saw the surface images and realized how rough Bennu was, were new tests run to try to determine, well, how are we going to actually acquire a sample, or what did they do once they realized it was such a rocky place?
Yeah, so like I said, they were looking for an area that was 50 meters flat, sandy, and they didn't find that at all. So all the sites that I showed were, 10 meters and with rocks around it. So they couldn't really test the equipment per se, but they could use the equipment to go closer in and take a look at these sites again and reassess the situation, and also perform new calculations with how they were going to safely land on Bennu. And I think they might have had to update, like I said, that natural feature tracking and hazard maps. So it was definitely a surprise and a shock, but our team definitely rebounded, and they found that they were actually able to navigate the spacecraft with higher precision than they planned for. So that definitely helps out a lot.
Excellent. Now, how long will it take for the team to know if this tag event was successful and they got what they were hoping for?
That's a great question. So the tag event is on the 20th, and I believe 2 days after the event, the camera will look at the tag head to make sure that there is material there. And then 2 days after that, I believe they will go into that spin maneuver to calculate the mass that was likely acquired. And I think I read that it takes about 18 or 19 minutes for a signal from the spacecraft to reach us. So once it does that maneuver and does its calculations, I believe we'll know within, I think, 4 days from tag that how much we acquired. And again, if we don't acquire that 60 grams, then we have the secondary site to go to. But that won't happen until January if we need to go there. Just to give time to prepare the spacecraft again and get back into the proper orbit and everything to get to the site safely.
Well, I know everyone out there is likely hoping that this first time works like a charm, and so I'm sure everyone out there will be watching. So our last question, which is perhaps a little less Bennu related, but more perhaps Ann Wynne related. We've got a Truman Elementary group, and I'm sure there's others out there that kind of just want to know what's it like to be a NASA scientist and a NASA scientist working on the OSIRIS-REx mission.
I don't know if words can really describe it. I feel like it's almost living in a dream state. Like I said, when I was young, I wanted to be an astronaut, and it's so surreal to actually be I'm not an astronaut, but to be touching and studying parts of rocks that are in space, rocks that are similar to material that formed Earth, where we live right now, is just amazing. And studying things that are as far away, that have been out in the Kuiper Belt, it's like a dream world, really. Just learning new things every day. And the teamwork page that you mentioned is really special as well. better and bigger things can be achieved if you have a great team and you work well together. I truly believe that. And not only the OSIRIS, the huge OSIRIS-REx team, but also our group, our smaller group here at Johnson Space Center. When we put our minds together to figure out problems, we can really, really analyze to higher capacity. And I just want to thank you all for coming and listening to OSIRIS-REx.
Awesome. And thank you so much, Anne. And thank you to all of you that took time out of your day today to join us for this OSIRIS-REx at Bennu webinar. We're especially thankful to Anne and Nicole for their time and efforts in sharing not only their knowledge, but their passion and what this means to them. Those folks out there and those young individuals out there, if you can get a job and love what you do, you'll never work a day in your life. And so doing what you love just makes it fun, and you can see it and hear it in what Anne and Nicole has shared with us today. So with that, we'll officially bring things to a close. We'll send out links for the archive that you all can watch and be able to rewatch. Again, I put a little survey in the chat as well for those of you that are on the Zoom webinar, and we'd appreciate any feedback you have for us. So thank you again, everyone. Thank you again, Anne. Have a great day, and go OSIRIS-REx. Looking forward to the 20th. All righty. With that, we're officially bringing this to a close. Thank you, everyone.
Thanks, everyone. Have a great day.
So our recording